Alright, picture this. You're not just sitting on Earth watching space missions anymore. You're on Mars, stepping out of your base, feeling the red dust under your boots. The sky has a soft pink glow, and you can see Earth, just a tiny blue dot in the distance. But here's the real kicker. What if I told you that SpaceX is working on an idea that could make this a reality sooner than you think? It's called the Mars Ionic Satellite System, and even though it's still an unofficial concept, it could change everything. This system would make communication between Earth and Mars as smooth as sending a text here on Earth. Sound exciting? Stick around, because in the next few minutes, we're going to dive into how this could revolutionize life on Mars and space exploration as a whole. Alright, let's jump back into that picture we were painting earlier. Where were we? Oh, right, yes, you, living and working on Mars, staying connected to the rest of humanity. You're part of this pioneering community, working on cutting-edge research, exploring places no one has ever been, and building a new home for the future. Every day brings something new, a fresh challenge, a chance to push boundaries, and an opportunity to make history. But there's one thing you might not have thought about. How do you stay in touch with Earth and the other explorers on Mars? Communication isn't just about sharing data and research, it's also key for keeping up morale and staying connected. Imagine being able to video call your family back on Earth or send a quick message to a fellow explorer on the other side of Mars. I mean, we're talking about a planet that's over 50 million kilometers away at its closest. That's a huge distance, and it makes real-time communication tough. The time delay for a message to go from Mars to Earth and back can be up to 24 minutes, which means instant communication just isn't possible with the tech we have right now. So how do we create a reliable communication network between two planets? This is where advanced technology and some serious innovative thinking come in. We need a system that can handle those huge distances and time delays, making sure messages get through quickly and reliably. Well, here's where it gets really interesting. Companies like SpaceX are leading the charge in this technological revolution. They're not just focused on getting us to Mars, but on keeping us connected once we're there. Their plan includes creating a network of satellites orbiting Mars, building a communication bridge between Mars and Earth. SpaceX might have the answer, an idea so bold it almost feels like science fiction, but the kind of thing SpaceX actually makes happen. They're working on tech that could make communication between planets feel as easy as sending a text message here on Earth. I'm talking about the Mars Ionic Satellite System. It's an unofficial concept right now, but one that could completely change how we stay connected with Mars. This system would use a network of satellites to relay signals between Mars and Earth, cutting down the time delay and making communication way more reliable. And stick with me, because over the next 10 minutes, we're going to dive into how this system could make life on Mars not just possible but practical, and maybe even comfortable. We'll break down the technology behind it, the challenges we'll need to tackle, and the amazing possibilities this opens up for the future of space exploration. By the end of this, you'll see how we could be communicating across planets as easily as we do here on Earth. Imagine a future where distance isn't a problem anymore, where we can share our experiences, discoveries, and even our daily lives with people on another planet. That future is closer than you think, and it all starts with the Mars Ionic Satellite System. Okay, let's talk about why we even need a satellite system around Mars. Sure, landing humans there is exciting, but think about the long-term picture. You don't just land and survive, you thrive. And to thrive on Mars, we need constant communication between Earth and Mars, between different Mars bases, and even between rovers and drones exploring the surface. Imagine being a Mars explorer, stuck in the middle of a dust storm with no way to call for help. That's not just inconvenient, it's dangerous. Now, you might be wondering, how can we create a network reliable enough for an entire planet? The answer lies in ion propulsion technology. This is where things start getting exciting, and I promise we'll dive into the details in just a moment. But first, I want you to understand the scale of the problem. Mars is far, really far. Depending on where it is in its orbit, messages from Mars to Earth can take anywhere from 4 to 24 minutes to arrive. Let's put that into perspective. You're on Mars, and you send a critical message to Mission Control back on Earth. You're in a life-or-death situation, but your message doesn't even get to Earth for at least 4 minutes. And then, after they receive it, it takes another 4 minutes for their reply to come back to you. Now think about how that affects everything, from scientific research to day-to-day communication. That's a huge delay, and it's not something we can just ignore. We need to build a system that allows for continuous communication, regardless of those time gaps. That's where the Mars Ionic Satellite System comes into play. So, what makes ion propulsion so special? Why is it considered a game changer in the realm of space exploration and satellite technology? Most satellites we use today rely on chemical propulsion, which is like using a lot of gas in a short amount of time. This method is effective for quick bursts of speed and rapid adjustments. However, while chemical propulsion is great for these quick adjustments, it burns through fuel at an incredibly fast rate. This means that satellites using chemical propulsion need to carry a large amount of fuel, which adds to their weight and limits their operational lifespan. Ion propulsion, on the other hand, is like a marathon runner. It doesn't rely on short bursts of energy, but rather on a consistent, steady push over a long period. By firing charged ions, ion propulsion provides this small, steady push over time. The result is a highly efficient system that uses fuel much more sparingly. These satellites can keep adjusting their orbits for years without needing to refuel. This extended operational capability is crucial for long-term missions and deep space exploration. This is critical for Mars. As we plan for more missions to the Red Planet, the need for reliable, long-lasting communication becomes paramount. We need satellites that can stay in position, adjust to new demands, and provide a constant stream of communication. Whether it's relaying signals from Mars to Earth or simply allowing different parts of Mars to stay connected. This constant communication is essential for the success of any mission, ensuring that data and information can be transmitted back and forth without interruption. And here's where it gets even more interesting. Imagine the possibilities when we combine ion propulsion with the latest advancements in satellite technology. SpaceX could potentially use Starship to deploy these satellites in orbit around Mars, creating a robust network that supports both scientific research and future human missions. With each mission, this network would grow, enhancing our ability to explore, communicate, and eventually inhabit Mars. The future of space exploration is bright, and ion propulsion is a key part of that journey. Now imagine this. Every time Starship makes the journey to Mars, it's not just bringing humans or supplies but also satellites. A fleet of ion-powered satellites deployed in strategic orbits, covering every corner of Mars with reliable, uninterrupted communication. These satellites wouldn't just sit there, they'd be actively maintaining their positions, using ion propulsion to adapt to Mars's changing conditions. Think about what that means for future missions. No more communication blackouts, no more long delays between sending and receiving critical information. Whether you're an astronaut on Mars, a scientist controlling a rover, or even a researcher back on Earth, you'd be connected in real time, or at least much closer to it. And here's the kicker, these satellites wouldn't just rely on fuel or batteries, they'd be solar powered, and I'll explain why that's key in just a minute. Alright, let's talk about power. Mars is farther from the Sun than Earth, which means it gets only about 40% of the sunlight we do. That's not a ton, but it's still enough to power a network of satellites if we use the right technology. And who better than SpaceX to figure that out? After all, they've already integrated solar technology into their Tesla cars and their Starship design. These satellites would be designed with large solar panels that capture the weak Martian sunlight, turning it into the energy needed to run their systems and power their ion engines. The beauty of this setup is that it's self-sustaining. Once the satellites are in orbit, they don't need constant human intervention. They're powered by the sun and can continue adjusting their orbits to keep communication flowing smoothly. Now here's something I've been thinking about. This system wouldn't just be useful for communication between Mars and Earth, but it would allow different Mars bases to stay connected. Let's say we have a research station on one side of Mars and another base on the opposite side. With these satellites in place, they'd be able to communicate instantly. Scientists could collaborate on experiments, explorers could share terrain data, and emergency alerts could be sent immediately. But it gets even better. Imagine being able to track the weather on Mars in real time. Mars is famous for its dust storms, and they're not just inconvenient, they can be deadly. A satellite network like this would allow us to monitor the planet's atmosphere and predict these storms before they hit, giving explorers time to prepare or take cover. And speaking of preparation, stay with me because in a bit we'll talk about how this system could enable something even more futuristic, real-time resource mapping on Mars. Imagine a rover traversing the Martian landscape, sending back data in real time. Scientists on Earth could analyze this data instantly, making decisions on the fly. This would revolutionize how we conduct missions, making them more efficient and safer. And it's not just about safety and efficiency. This system could also support sustainable living on Mars. Imagine being able to monitor and manage resources like water and food in real time. Energy management would also benefit, ensuring that power is distributed where it's needed most. This kind of connectivity would make life on Mars not just possible, but practical and sustainable. So, as we look to the future, it's clear that a robust communication network is key. It's the backbone that will support all our endeavors on the Red Planet. Stay tuned, because next, we'll dive into the exciting possibilities of real-time resource mapping and how it could change everything. The future of Mars exploration is bright, and it's just beginning. So, what's the big picture here? With this Mars Ionic satellite system in place, we could essentially create a Martian internet, one that connects every corner of the planet, providing a continuous flow of information. Astronauts wouldn't just be surviving on Mars, they'd be thriving, collaborating across vast distances, sharing data, and responding to emergencies in real time. And let's not forget the impact this could have on Earth. Scientists back home would be able to access massive amounts of data from Mars without the long delays we're used to. This opens the door to more discoveries, faster. Imagine a future where we're constantly receiving updates from Mars, weather reports, new terrain scans, even potential signs of water or life. I think what's really exciting about this concept is that it's not just about survival. We're talking about creating the infrastructure needed to live on Mars, to explore it fully, and to do so in a way that feels connected to the rest of humanity. This isn't just an isolated mission, it's the foundation for building a society on another planet. And if you're still with me, I want you to imagine something even bigger. Imagine we get this satellite system in place and it works perfectly. What's next? Could this be the first step toward a network that expands to other planets? Could we create a similar system around the moons of Jupiter or Saturn? I know it sounds far-fetched, but that's exactly what people said about landing reusable rockets a decade ago, and look at us now. So what do you think? Could the Mars Ionic satellite system be the key to unlocking our future on the Red Planet? Personally, I think this could happen much sooner than we realize. SpaceX has already proven they can make the impossible possible, and this feels like the next logical step forward. I can't wait to see how this unfolds, and I'm betting we're going to hear a lot more about this in the coming years. If you're as excited about space as I am, hit that like button, subscribe, and stay tuned. There's so much more to explore. Thanks for watching, and as always, keep dreaming big and looking up.